guys. Very good. Yes, very good morning, all of you. So, yes, we continue our discussion on the aromaticity topic. Everyone can hear me properly, please. One. Very good morning. All right. Now we are going to see the application of all the concepts that we have discussed. All right. Yes, very good. Very good morning once again. So, we are going to discuss three concepts that we have already discussed. We are going to see some questions. All right, so we have talked about the quasi-aromatic system, homoaromatic system, or uh, non-benzenoid aromatic compounds with respect to the Craig's rule. Everything we have already discussed, right? Yes, so now what we are going to do today, we are going to move onwards and see. Today we are going to move onwards and we are going to see some examples. So first of all, reminding once again that Battle of Pole sessions are being conducted every day 6 p.m. These are free practice sessions. Reaction mechanism is already done. All right, in those free sessions, we are doing the reactive intermediates right now. All right, you can just visit my profile and check all of these free classes. And to unlock, you are going to use the code Jagriti S. This is to unlock the feature free of free classes. Also, if you're interested in joining an Academy Plus, my courses which are ongoing right now is a spectroscopy course. Also, I am doing bioinorganic chemistry. Not only these, all the topics of organic chemistry as well as inorganic chemistry are complete. You can just visit my profile and check out. Also, if you are interested, you can join from any of these subscription packages for Iconic or for Plus subscription, and by using the code Jagriti S Live, you can join up. Okay. And once you join, please message me on Telegram so that I can guide you what to do next after joining an Academy Plus. Okay. Yes. Now let's continue our discussion, guys. Now the question comes like this. Very, very simple question. Question comes like this: ki what is the resonance energy, or let's say what is the measure of aromaticity? या फिर arrange the following molecule. Arrange the following molecules in the order of in the order of aromaticity. Then how are you going to say pyrrole system, thiophene system, have furan, have benzene, then you have pyridine. These are the basic system, guys, and if you remember the values, it's going to be really great. But anyways, how are you going to say? Yes, good morning, guys. Good morning. Okay. So for these, arrange the following molecules in the order of aromaticity. If I have numbered 1, 2, 3, 4, and 5, what will you say about it? Yes, very simple. You just have to, these are the very basic systems, which value you can remember. So we are starting from benzene, guys. The maximum energy is 36 kilocalorie per mole. This is the energy for the benzene. This is going to be the maximum. So 4 is going to have the highest aromaticity or the resonance energy. All right, 29 kilocalorie per mole for thiophene. Then comes 2. All right, then comes 28 kilocalorie per mole. All right, now this is going to be number 5 on the third position. Then comes your pyrrole molecule, 21 kilocalorie per mole. Then comes first one, pyrrole molecule, right? And then finally you have furan, 16 kilocalorie per mole. Okay, so this is your third one. So this is the order of aromaticity or resonance energy. Both are the same thing. Yes, Ayush, I will tell you in a while after doing few questions. Then we can discuss. And also you can message me on the Telegram channel, right? You can message me personally on Telegram. Okay. Now, yes. Now what happens is, this is one question we have done on the same concept. Let's do more questions. Yes, pyridine का ज़्यादा होगा, pyridine का ज़्यादा नहीं है, pyridine का 28 किलो कैलोरी पर मोल है with respect to benzene. So yes, 36 kilocalorie for benzene and 28 kilocalorie for pyridine. Okay. Also, yes. Also, let's discuss one more question like this. That is, arrange the following compound. Now, this is our question number 2. Arrange the following compound in correct order of aromaticity. In the correct order of aromaticity. Okay. Yes. Now, you have benzene A, you have naphthalene B, and you have anthracene. So you don't have to remember the values in this case. You cannot do so. What you have to do is you have to just see what is going to be the order of aromaticity. And let's say, yes, and let's say even I give you the values. I'm giving you the values of resonance energy. Benzene का आपको पता है, benzene is going to be 36 kilocalorie per mole. Naphthalene is 59 kilocalorie per mole, and for anthracene it is 71 kilocalorie per mole. Yes, but still you have got the resonance energy, but still the order of aromaticity is going to be A greater than B, which is greater than C. ऐसा क्यों है guys? Why is that so? Yes, why is that so? Because when we say we want to see aromaticity, we want to check this concept per ring. So aromaticity is the property of each different ring. हाँ, so it is the property. Aromaticity is the property of each ring. So we find out कि जो resonance energy है per one ring, how is it going to be? Resonance energy per cyclic ring, how much it is going to be? So benzene में क्या होता है? 36 upon 1, because there is only one ring, so this is equals to 36. All right. In the case of B option, so resonance energy per ring is how much? 59 upon 2, because there are two rings. So how much is it, guys? This is coming out to be 29.5, isn't it? Yes, good morning, guys. Good morning. Who are joining now? Subhash and everyone. Okay, Smita. Right. So 29.5 kilocalorie per mole. Yes. What about option number C? Here, the resonance energy per ring is going to be 71 upon 3, because there are three rings over here. So we are just going to divide this by 3. How much is it going to be? 26.6. 26.667, it is going to be like that. You can just write 26.6. All right. So this is it. Now you see the resonance energy per ring has reduced. This is 36. This is 29.5 kilocalorie per mole, and this is even less, 26.6. So when the number of rings are increasing, the resonance energy per ring is going to decrease. That is why the stability order or the resonance energy order or aromaticity order, both of these are going to be this. A is greater than B, greater than C. And yes, this is understood to everyone. Very, very important. Yes. 26. एक सेकंड चेक करते हैं वापस. 3 2s are 6 and 1 1 11. हाँ सॉरी 3 आएगा 9. 23.6 आएगा. Yes, it is 23.6. All right. Okay, even less, 23.6. Yes. So this is it. Now there is one more important concept regarding the same thing. Ki, aromaticity is the concept used for a single ring. What is that concept called? It is called the annihilation effect. It is called the annihilation effect. What is annihilation effect, guys? ये क्या होता है? That is, each ring in the fuse system is, it's going to be the part of aromaticity. लेकिन once again, aromaticity तो एक ring का concept है. मतलब कि let's say if I'm talking about the cyclopentadienyl anion like this. Yes, the cyclopentadienyl. There are 6 pi electrons over here. This is very happy molecule because it has the 6 pi electron. It is cyclic, planar, aromatic है, ठीक है, very stable. What about this system now? Yes, tell me one thing, that benzene is definitely aromatic. ठीक है. Yes, benzene is definitely aromatic. पर ये वाला जो benzene है, this benzene, is it going to be as aromatic as your simple benzene? अगर मैं बात करूँ, I am only looking at this ring and this ring. Is it going to be the same 36 kilocalorie per mole? Yes or no? Is it going to be the same 36 kilocalorie per mole? जैसे कि ये ring है benzene and this ring. No, it's not going to be the same. Why? Because no, it's not going to be the same. Because one double bond is sometimes, it is this double bond over here is sometimes going to be in the 5-member ring, sometimes it is going to be in the 6-member ring. So I can say aromaticity decreases. Yes, aromaticity decreases, right? Okay, so the same thing I can say for the 5-member ring also, that this ring is more aromatic. The individual cyclopentadienyl ring is more aromatic as compared to this ring over here. That also I can say. And this is going to be more aromatic. The central ring is going to be more aromatic as compared to this ring over here, isn't it? This is going to be even less aromatic, least aromatic, I would say. This is going to be least aromatic. Why? Because the double bonds are being shared into two different rings. So इसीलिए I would say this is 1, this is 2, and this is 3. So I would say the aromaticity order, aromaticity या फिर resonance energy order of the cyclopentadienyl ring, Cp minus ring, is 1 greater than 2 greater than 3. This is known as the annihilation effect. कि जैसे ही number of rings increase होंगे, per ring the resonance energy will decrease. Okay, number of benzene ring increases, the aromaticity for the central CP ring, that decreases. Okay. Yes. Now, all right. Now let's discuss. Yes, this concept is understood. What is the what is the annihilation effect? Yes, we are going to move onwards and we are going to see more examples. Okay. All right, chalo. So now the example I'm going to ask you is on a different concept. It is based on the dipole moment. So I ask you ki which of these molecules will have maximum dipole moment? Which of the following molecules is going to have the maximum dipole moment? All right. Let's say I'm drawing the heptadene in option A. This is an oxygen over here. This is a double bond over here like this. This is your molecule. All right. So what is the, or let's say which is the maximum dipole moment, or you can also say the order of dipole moment in the decreasing order, right? The one which is having the maximum dipole moment in the first step. Yes. What will you say? Yes, everyone. What is the order of dipole moment? So in these molecules, the dipole moment order could be directly explained by the aromaticity, isn't it? Maximum dipole moment. Yes, Smita, very good. So absolutely, dipole moment is the separation of charge. Now, this molecule, heptadene molecule, haven't we discussed that because of the, we have found out from the Craig's rule, this is going to be non-aromatic system? Yes, haven't we seen that? Yes, this is going to be a non-aromatic system. And the non-aromatic system does not care very much about the delocalization. So delocalization is the property of aromatic systems, isn't it? Yes. तो ये नहीं करेगा delocalization. Now what happens in option number B? Over here you see that you can use the lone pair of oxygen, and if you use the lone pair of oxygen, the ring will become more stable definitely due to resonance, as well as it is imparted a little bit of resonance energy as well. So rings size जो है charge separation जो है that is happening. There is charge separation. Yes. What about option number C? This is going to be the most aromatic. Why? Because if you are removing this one bond from the azulene system, yes, let's say you want to draw the azulene in such a manner that you have this negative charge over here. Alright, that let's say this is one cyclopentadienyl ring system, and let's say this is your tropylium cation system, right? Which means, what am I saying, guys? The positive charge comes into the bigger ring, 7-member ring, and the negative charge goes into the 5-member ring. So it is definitely stable like this. because this system will become tropylium cation and this system is going to become the cyclopentadienyl anion, right? So maximum charge separation is going to happen in option number C. Okay, so the dipole moment order is going to be C greater than B greater than A. Alright, this was a very simple question, everyone. Yes, good morning all who are joining now. Let's do another question. So, just a simple question. Which of the following compound is more stable? Is more stable. Alright, let's say you have this species and this species. Alright, so which of them is going to be more stable? Very direct question. Which of them is going to be more stable? See, now when I said that greater the pi conjugation, greater is the stability. So when we were talking about all the three different types of molecule, that is A molecule over here, B molecule over here and C molecule over here. So यहाँ पे भी तो pi bonds increase हो रहे थे ना? Then why did I say that 3 is going to be 3 is going to be least aromatic per ring? Because the number of pi bonds were divided in between the two rings. ठीक है, क्रॉस कॉन्जुगेशन हो रहा है, divided in between two rings. लेकिन यहाँ तो ऐसा नहीं हो रहा. Here in just one ring you are increasing the conjugation, so definitely the order of stability is going to be A greater than B greater than C. Yes or no? Yes, this is how it is. The resonance energy is going to be high for A and then B and then C, right? Also if you are talking about, yes ये सही है यहाँ पे resonance के हिसाब से. Okay, also now if I ask you, I have these molecules. ये दूसरा question है. Once again, which one is more stable करके. Question number 4. If I ask you the same thing over here, yes, which of them is going to be the most stable? All right, just one let's once again see question number 3 guys. यहाँ पे हम ऐसे नहीं करेंगे. We are going to look with respect to the number of electrons. So you are having 6 electrons per 7 carbons in option number A, which is going to be less than 1 ratio. This is going to be 6 electrons per 5 carbon. Alright, so this is going to be greater than 1 ratio, and this is once again 2 electrons per 3 carbon. Alright, so this is also once again less. So your maximum is going to be B. B is going to be the most stable, right? Because इसकी electron density सबसे ज़्यादा है per carbon atom, right? Yes. And what about the other one? Coming out to be something like 0.85. Okay. This 0. What you can do, you can write B is greater than A and greater. This we are going to say with respect to the electron density. इलेक्ट्रॉन डेंसिटी मोर रेजोनेंस ऐसे लिख सकते हैं इसको, ठीक है. A is greater than B greater than C नहीं लिखेंगे. Alright, B is greater than A because of the charge, because same है ना, A and B are having the same charge. Yes, 6 pi electrons are there. So when there are same number of electrons, then you consider the charge density. Yes, तो मैम प्लस चार्ज का. Yes, see what happened. Yes, Ayush, इसको देखो. You have 6 pi electrons over here. Yes, प्लस चार्ज के लिए माइनस नहीं करेंगे because obviously you don't have any electron density, but then you have a vacant p orbital. So the vacant p orbital is only going to help in the delocalization, and it is going to make the system planar. ठीक है, इसीलिए we are considering 6 pi electrons. So 6 pi electrons के लिए A is going to be less aromatic than B, which is also having the 6 pi electron. Alright, like this. Okay, this is going to be greater than 1 ratio. Alright, 1.2. Chalo, this is it. Now, about this one, second one, इसमें तो सब anti-aromatic है, isn't it? All of these are anti-aromatic, yes or no? This is also having 4 and 5 electron system, इसके पास 8 pi electrons है. This is going to have once again 4 and 5 electron system. This also 4 pi electron system. Yes, now how do you find out the stability? Yes, tell me one thing. ये जो सबसे छोटा वाला है C option, is it bound to be planar? ये non planar तो हो नहीं सकता. When the molecule becomes anti aromatic, it will tend to become non planar and puckered in nature, or delocalization कम हो जाएगी, and it is going to be more stable. But this option number C, this is most planar. If it is most planar, so definitely it has to do resonance, and this is going to be most anti-aromatic. This has to be most anti-aromatic, isn't it? तो अब ये सबसे ज़्यादा anti-aromatic है because maximum planarity. Option number 1, least planar. Okay, least planar it is going to be, and that is why it is more stable than option number C, क्योंकि ये पकड़ हो सकता है big ring, right? What about option number B? This also once again, yes, it has less number of pi electrons. It has less number of pi electrons than A. So B or C को compare करो guys. B is going to be more stable than C. Yes or no? B is going to be more stable than C. And what about A? A is going to be less stable than B. So I can write B is going to be greater than A greater than C. ऐसे लिख सकते हैं. Once again. All right. Or you can also consider कि चलो ठीक है, it is having more number of electrons, but this is going to be least planar. It can be most distorted. Maximum distortion it could make, so least delocalization. So you can also consider this answer, right? A is greater than B greater than C. ये भी consider कर सकते हो, यही सही है. ठीक है, चलो. Based on planarity. Alright, so you can consider based on planarity. फिर ये matter नहीं करेगा how many pi electrons you are having. Alright, so we move onwards and we discuss more questions. Now, who is going to react? The question goes like this. Which of the following compounds which of the following compounds readily gives hydrogen gas with sodium metal? Okay, like this. So, which of them is going to readily give up hydrogen gas on the reaction with sodium metal? Everyone, so when reacting sodium metal with this molecule, the second is going to be the reaction. This option इतने ही है, two options. So that is here for the hydrogen. What do you have? Sodium is going to transfer electrons to hydrogen. You are going to generate one hydrogen radical from here. One more electron, when it is given to, becomes cyclopentadienyl anion. Half of the hydrogen is eliminated from here. So one molecule sodium is going to provide one electron to hydrogen and the bond opens up like this. Okay. So one molecule of Cp is going to give you half hydrogen, matlab ki only one hydrogen atom. Right, so two molecules of Cp, they are going to give you one hydrogen molecule, right? Very easily it is going to remove the proton. Why? क्योंकि अगर इसने एक proton lose किया, it is going to become aromatic. So the question is asking you which of the following compound it readily gives hydrogen gas with the sodium metal. So B is going to be the answer. What about option A? It can take electron density from sodium. Alright, ये सोडियम से क्या करेगा? कोई हाइड्रोजन पे इलेक्ट्रॉन डेंसिटी नहीं ले रहा है. Two atoms of sodium can give the electron density to this molecule. It is having 8 pi electron system. It is non-planar. When you have when you have two electrons transferred from sodium, you are going to have two negative charges like this. कितने pi electrons हो गए guys? 1 2 3 4 and 5, so total 10 pi electrons. Now it is aromatic. Now it is going to be planar. Okay, yes, this is what you have. Does it make sense? All right. Okay, very, very simple. All right, then let's do a match the following question. So this is your column number 1, this is column number 2. All right. And the option number D. Okay, I'm writing option D over here, okay? So there are D and E also. Okay, this is N, okay? So in the column 2, you are having first is aromatic, second is non-aromatic, third is anti-aromatic, fourth is heterocyclic. Now you have to tell me what how are we going to match? I'm not going to have four options. आपको यही बताना है who is going to match with whom, and it could be more than one correct answers, okay? Chalo, done. This is the last option, heterocyclic. This is heterocyclic, I've written, plain simple. Right, what do you say? Could be more than correct one correct answer, जैसे कल किया था वैसे ही. All right. So let's check some answers. फिर मैं पोल बना दूं तो यहाँ पे सब आंसर कर देंगे. Like this, nobody wants to answer, isn't it? A, B, C, D you'll answer. चलो. So first one, as I said, there could be multiple correct answers. So for first one, what is it? Oxazole. One is aromatic, two is non-aromatic, three is anti-aromatic, four is heterocyclic. It is very simple and visible. Yes. Yes, Smita, you can reply in English. All right. So A is going to be aromatic. So first one is correct for A, and also it is heterocyclic. So fourth is also correct for A. ठीक है? 1 and 4 both will match for A. What about B? B is also heterocyclic. What is heterocyclic? Where you are having heteroatoms in the cycle, not only carbon. There will be nitrogen, phosphorus, oxygen, and so on. ठीक है? What about this molecule? You can use the lone pair of the nitrogen cause resonance like this. The ring is going to look in this way. Yes, it is going to look like this. So isn't it aromatic? It is absolutely. B is heterocyclic. It is also aromatic. Yes. What about C? Yes. What about C? C is also aromatic. Yes. Slightly aromatic. ये burazine molecule है. So burazine is your inorganic benzene. It is also considered to be aromatic in nature. Also it is heterocyclic. So 1 and 4 both are correct. What about option number D? D के लिए क्या correct है guys? How many number of electrons are involved? Yes. How many number of electrons? Also, it is not fulfilling the Huckel's rule because there are double bonds in different rings, isn't it? Yes. तो ये जो system है ये aromatic नहीं हो सकता है. It is going to be non-aromatic like this. What about option number? Yes, E. This is your option number E. What about this? It is heterocyclic definitely. Without any doubt, you can write it is heterocyclic, but also it is going to be anti-aromatic. Yes, anti-aromatic. Yes. So ये correct है. E is going to be anti-aromatic. So this is how you had to match. Okay. As I had said, it could have more than one correct answers. These options. This is how it's going to be 1. This is going to be 3 and 4. Yes. चलो फिर. Let's do one more good question. नहीं चेतन, मल्टीपल के लिए ऑप्शंस आते हैं. दैट इज व्हाई आई had told you कि I'm not making those options, but then you can do it correct. All right. So the product A is anti-aromatic, homoaromatic, non-aromatic, and simply aromatic. Yes. What is it? Yes. स्ट्रक्चर में COOCH3 है. I don't know. Yes. So what is the characteristic of the product, guys? You tell me quickly. So you're saying B. What about everyone else? So what is this combination, guys? Can you tell me what is this combination? Super acid combination, isn't it? Yes, absolutely super acid combination. So what is this super acid combination going to do? Yes, super acid. So what is it going to do? It is going to replace this whole group. Yes, isn't it? ये क्या कर सकता है यहाँ से? It can replace this whole group and it would hydrolyze this whole system and it is going to, ये देखो, अगर मैं बोलूँ कि मेरे पास H plus है, because it is a super acid, it is going to provide you H plus, which is so strong that I can directly protonate this methyl group. Methyl protonation करवा सकते हैं, and I am removing the electron density from this system. So there is a double bond, there is a positive charge, there is CO2 and there is CH4, like this. Does it make sense? In this way, क्योंकि ये proton है and the proton is really really strong, so this methyl, the methoxy bond can break. Methoxy bond के electrons methyl के पास चले गए हैं. It has become CH4 and the electron is being removed from the single bond over here. So this is what you are going to get. This is the new species that you will get in the presence of the strong acid. What is this? इसको देखो. What was the definition of homoaromatic compounds? It was कि your system is going to have delocalization, and if it follows the Huckel's rule, और एक carbon saturated carbon है, one of the carbon is a saturated carbon, like this. Let's say this is your saturated carbon. It is still a four membered ring only. 1 2 3 and 4, अभी भी four membered ring है, लेकिन एक double bond है और एक positive charge in this way, and it can do delocalization like this. It can do delocalization to a three membered ring system. अब three membered आपके पास पहले से example है guys. This cyclopropynyl cation, it is aromatic in nature. Similarly, this system, cyclobutyl cation, like this, that is also going to be homoaromatic. This makes sense? Yes or no? Very very good question this is. बहुत अच्छा question है. It is a homoaromatic compound. Carbon. Very good. Chalo. Now we move onwards and we see more examples. Which of the following compound is aromatic? Okay. Which of the following compound is aromatic? Yes, absolutely. Very good. Very, very good, all of you. Very simple question. This is who is going to be aromatic? Absolutely the one which is going to be similar to the system having 6 pi electrons. अब ये देखो. This molecule is similar to a carbocation, isn't it? Because carbon के पास क्या होता है? Carbon, when it forms a carbocation, has a vacant p orbital, isn't it? It has a vacant p orbital when it becomes a carbocation. Same thing is happening with boron. Boron के पास तो वैसे ही vacant p orbital है. It is sp2, so it can do resonance. It is also vacant. How many number of pi electrons? 4 and pi electron ही बचे. 4 pi electron बचे. So this is anti-aromatic. About option number B, if you consider a vacant p orbital over here, so how is it going to be? ये देखो, ये सिस्टम पूरा कैसा दिख रहा है? Like the tropylium cation, and the tropylium, yes, the tropylium cation is going to be aromatic. You know that already. Very good. Now what about this nitrogen? Nitrogen के पास lone pair है. If it is using the lone pair into the system, right? See, without using lone pair, it cannot give delocalization क्योंकि vacant orbital है नहीं. अगर lone pair use किया, so it's going to become a 4 and pi electron system या फिर 8 pi electron system, which is absolutely not stable, anti-aromatic हो जाएगा. What about this molecule? Yes. Even if it does resonance in this way, there is one NH bond यहाँ पे आएगा positive, one NH bond यहाँ आएगा. Isn't it? So even if it is doing a little bit of resonance, it could be aromatic, but not 100% sure about this, right? लेकिन B sure है. ठीक है? B is absolutely sure, aromatic in nature. चलो. Alright guys, so these are some of the questions that we have done today. बहुत सारे question हमने कर लिए हैं. Plenty of examples we have discussed. Also, yes, Ayush, once again I am informing you all that there are plenty of topics which I have already completed. Let me just list them down quickly. So in the organic chemistry as well as inorganic chemistry, plenty of topics which are completed. We have done the reaction mechanism. Alright, this was done in the free classes. In the special classes in the month of April, if you want, you can just visit my profile and check out everything from there. Also, reactive intermediates. Reactive intermediates was done in the plus class in the month of April. Alright, then we have also completed in the inorganic chemistry, we have done coordination, chemical bonding, organometallic chemistry. All of these three biggest topics are done in the inorganic chemistry. You will find in my profile inorganic chemistry detailed course. Bioinorganic is also done. What are we going to start? We are going to start the main group. ये हम अभी start कर रहे हैं. ठीक है, all of these topics are done. You can visit my profile and check from there. Pericyclic and photochemistry. Alright, this is also there in the plus class. Stereochemistry, once again done in the free sessions. Heterocyclic chemistry, once again in the free session. Alright, और heterocyclic के बाद में हम कर रहे हैं aromaticity, acid and base, chemical, carbohydrates, amino acid, all of these four topics we are doing in the YouTube. Okay, that you already know. So this is what you are going to get on my profile. Okay, all the organic and the inorganic topics right now, and you can just check my profile and join Unacademy Plus through the code Jagriti S Live. Okay, but first take the benefit of all the free classes starting from April to May to June. बहुत सारे free classes हैं, बहुत सारा पढ़ लिया है हमने. Okay, so take the benefit of that as well. Alright, so now I am going to see all of you in the 10:30 a.m. session on Unacademy. Yes. So bye everyone. I'll see you very soon, guys. Have a great day, everyone.